Okay, so let's start. So in the previous class, actually we were discussing the functional group. Okay, so let's write the functional group. What are functional group? Functional groups are the, we can say, the compound of hydrocarbons or an atom or a group of atoms. Do we have written the definition of functional group? Tell me.
Uh, yes,
Yeah,
sir.
we have written. Yeah, we have written an atom or a group of atom attached to an hydrocarbon chain that determine the physical and the chemical properties of the hydrocarbon is called functional group. Okay.
Functional.
So,
Yes, sir.
so there are different types of functional group that we have. Okay, functional group. Okay, the first one is, if I talk about the functional group is that like we have the, I'm just going to make here. The first one is just carboxylic acid. So first name is serial number, then functional group, functional group name. Okay, then its structure. Okay, structure, and then its suffix, prefix, and then suffix. The first one is functional group. If I talk about the carboxylic acid, the functional group is, its name is carboxylic acid, oxalic acid. Okay, it is like COH, and its structure is C double bond OH. Means it will be written in the hydrocarbon chain like this way. Okay, and its prefix is, there is no prefix, and what is suffix for this one is oic acid. We'll discuss that what is suffix, what is prefix later. The first let's write all the functional groups. Okay, this, the next one is, aldehyde, and it is CHO, and it's in the structure is C double bond OH. Okay, there's no prefix here. The suffix for is al. Third one is ketone is C double bond O or CO. Ketone is CO, functional group. The structure is C double bond O, and its prefix is on. The fourth one is alcohol. Alcohol is OH, and the structure is also OH, and its suffix is all. Noted down. Done, everyone?
Sir, did we write down anything before this?
Yeah, you have to write down all.
No, sir. Did we write anything before this in today's
No,
class?
no. This is the first thing that we are just writing.
Okay, sir. Thank you.
Done? Noted? Noted?
Yes, sir.
What is the specific things of this three are that these three functional group has its own carbon, or we can say these three functional group has their own carbon. These three functional group has their own carbon. Okay, So if we need to write the simplest form of this one, so their carbon can be included. Okay, for example, if I want to write the simplest carboxylic acid, simplest carboxylic acid. If I'm going to write simplest carboxylic acid, okay. So if I want to write the simplest carboxylic acid, so it is going to have COH functional group. Okay. So you need to keep in mind that I need to, since it is going to have its own carbon, then this carbon has already made 1, 2, 3 bonds. So if I write another carbon chain here, then it will not be simplest because it is going to have 2 carbon. Simplest carboxylic acid means the acid with 1 carbon. So I can write here a hydrogen here. Okay. So in order to meet the requirement, means fulfill the valency of this carbon, I can write H here. So this is the simplest carboxylic acid. Okay, with 1 carbon. And okay, so this is simplest carboxylic acid with 1 carbon. Okay. Similarly, if I talk about simplest aldehyde, so aldehyde functional group is COH, yeah, CHO. So this functional group is going to have its own carbon. So since this has made 1, 2, 3 bonds, so I can write here 1H. So this is the simplest aldehyde. Simplest aldehyde. Okay. And you need to keep in mind, if I need to make it with another bond like this, there can be infinite number of carbon you can join here. Okay. And this is CHO. So this is also an aldehyde. This is of 3 carbon aldehyde. This is of only 1 carbon aldehyde. This is of carboxylic acid. So if I write it C double bond OH like this way, so if I start writing this chain, if I'm adding to this one instead of this hydrogen, then this will be the carboxylic acid of 1, 2, 3, 4 carbon. Got it? Are you getting my point? Are you getting my point? Tell me yes or no. Hello. Unmute yourself.
Yes, sir. Sir, can you show that functional group structure again? I'll take a screenshot.
You have not noted this one.
Yeah, sir. Actually, I came late. Done, sir. Thank you.
Okay. Now talking about this one, simplest carboxylic acid is, just look at this. This is the carboxylic acid CHO. If we this carbon is fulfilling the requirement for the simplest one, this one carbon is also, but in ketone is an exception here. Simplest ketone is of 3 carbon. Simplest ketone is of 3 carbon. Why? Because if you made this ketone with hydrogen like this and 1 hydrogen for this will become again aldehyde. If you have 2 carbon ketone like this, okay, like 1 carbon here, 2 carbon, or if you have to complete its valency 1, 2, 3 bonds, H, then it will again become aldehyde. So ketone is of minimum 3 carbon, means for making ketone at least 3 carbons is being required. So that C double bond of O should be there, C double bond OH should not be there, because if you put it at the termination carbon, the last carbon, then you have to fulfill, means you need to put 1 hydrogen, like if you put it like this way. So ketone cannot be at termination, means ketone functional group cannot be at termination, means end carbon or the starting carbon. Why? Because if you put, this carbon has made 1, 2, 3 bonds, so you need to make one hydrogen to make it fulfill, you need to react it with 1 hydrogen or make it with 1 hydrogen, so that it can make the all 4 bonds. Okay, so here now this will become aldehyde, not ketone. So for ketone, the simplest ketone is of 3 carbon. And ketone functional group can never lie at the termination. It can remain on the second, it can remain on the third, but it can never remain on the termination carbon. Okay. Got it? Understood? Tell me yes or no. Why everyone has muted?
Yes,
Oh,
sir.
turn on your
Yes,
camera,
sir.
everybody. Please turn on your camera. Turn on your camera, Charisma. And you, Abdullah Ashraf and Adil. Please turn on your camera.
Sir, I had net lag. I have informed you last class also.
You don't have? What are you saying?
Sir, I had net lag. I informed you last class also.
Wait a minute. Okay. Next. If I talk about the next one is, here you need to keep in mind that the next one is after the alcohol. Alcohol is the functional group which is not going to have any carbon. So for making the simplest alcohol, you need to at least add one carbon chain to it. Okay, this is CH3. One carbon chain is of CH3. So this is the simplest alcohol. Or you can make it like this. At least one carbon chain should be added to alcohol to become the simplest alcohol. And this is the simplest alcohol. This is the simplest alcohol. Okay, got it? Got it?
Yes.
So what you need to do here is that if I write it like this way, so the simplest alcohol need at least one carbon. For simplest ketone, we need at least three carbon, sorry. And for aldehyde, this functional group carbon is sufficient. For carboxylic acid, this functional group carbon is sufficient. Okay, so let's move further. The next functional group is 5. Okay, then it is alkyl group, or we can have the other one like nitro, and it is NO2. Its structure is N double bond O. Okay, and okay, NO2, and its prefix is prefix and suffix. We use prefix here for nitro. We have this prefix. We don't have suffix for nitro. Third one, the sixth one is halogen group. Halogen is like chlorine, bromine, iodine. Okay, this is called halogen. If means carbon chain is attached with some chlorine at the end, with some brome, or in the middle also. If chlorine, bromine, iodine is attached with the hydrocarbon chain, then we consider it as halogen. Okay, now you can write it. Their names are written in the prefix, like this chloro, like this bromo, iodo, etc. They have no suffix. The next one is the seventh one is alkyl group. Alkyl group. This is very important. You need to understand. Alkyl group is a group of one carbon, okay, or two carbon chain or three carbon. For example, we can say that alkyl group is a branch of hydrocarbon For example, this is a three. This is a this is CH3, CH2, CH2, CH2. Okay, sorry, CH3. Now, if I attach one hydrocarbon chain to it, okay, so one hydrocarbon chain is, if I attach, so this carbon has made 1, 2, and 3 bonds here with this hydrogen. So next will be this one. So this is CH3 group. So CH3, actually this is methane. This is whole. This is CH4. Like if I'm having C2H6, the formula for alkane is CnH2n plus 2, and the formula for alkyl group is CnH2n plus 1.
Yeah,
Plus
plus
1.
1.
Okay, you need to, if alkane is going to have CH4, then alkyl group of one carbon will be CH3. If alkane is going to have of two carbon is C2H6, then alkyl group will be C2H5. Okay, you need to understand this one. That alkyl group is one hydrogen less, because this is going to branch with another carbon. Okay, like this one. Like for example, C, like three carbon alkane will be C3H, 3 to the 6 and plus 2, 8. This is propane. Okay, and if I see C3H7 is propyl. C3H7 is an alkyl group. Name is propyl. Propyl. So you need to keep, you need to understood here one thing in deep and thoroughly, that whenever a hydrocarbon chain is attached, okay, this branch is known as alkyl group. This branch is known as alkyl group. Okay. So if one carbon is CH3, two carbon is C2H5, C2H5. It can be written in a group like this. Like this. This is C2. This is C. The two carbon chain is C2H5. How it can be? If it is attached with the main carbon chain, this two valency is free here. This is two hydrogen. And now this is going to have three. So this is C2H5. C2H5. C2H5 is actually a branch, a chain. Got it? So their names are known as, they are known as alkyl group. They are branch, and their names are written according to their IUPAC name. For example, one carbon chain is known as methyl, the two carbon chain is known as ethyl, three carbon chain is known as propyl. So this is important. Okay. So have you noted? Have you noted this one? And their names are written alkyl group names are written in prefix or as prefix. As prefix. Note it down, please. Done?
So 1 minute.
So one sec.
When you're done, please let me know. Okay.
So the prefix for iodine is iodo, right?
Yes, iodine, iodine. Yeah, chlorine for chlorine is chloro.
Okay, sir. Thank you.
Noted?
So the screen is not visible. It went blank.
It went black.
Yeah.
No, sir, it's clear.
हाँ sir, आ गया sir. Okay. Now it's fine.
Now, have you noted?
Yes, sir.
So tell me what is the correct answer for this one? Name the functional group present in this compound.
Sir, propanol.
Yeah, name the compound. This is of 3 carbon. Okay, so 3 carbon we're going to have prop. We're going to discuss and the functional group. I'm just asking only the functional group. Which functional group is present in this one? CHO, and CHO is aldehyde. Aldehyde. So if I talk about this is a question that if I'm changing the question, which functional group is present in this one? So which functional group is present in this one? Tell me.
CHO, aldehyde.
CHO, aldehyde. Okay. Will you remember this one?
Yes, sir.
Okay. Next, here we're going to have okay. Tell me which functional group is present in this one?
Sir, for AH, OH.
Alcohol. OH.
Sir,
Is
OH, and for
not
Alcohol.
OH. It is carboxylic acid. C double bond OH is carboxylic acid.
Okay.
oh,
This one. This one. First tell me this one. C.
CH.
Which functional group is present in this one? This is CH double bond O. You can rotate it like this way. Up to 270, you can C double bond OH. So this is same. If you make it like this, this is same.
So Al is.
Yeah, this is aldehyde.
Yes, sir.
Aldehyde. This one, tell me D. Which functional group is present in the D?
So OH.
OH is water.
The OH is alcohol, right?
Yes, OH is alcohol. Yes, you are correct. OH is alcohol. So this is alcohol. Okay, because C is not doubly bonded. So if C is doubly bonded with O, then it will become carboxylic acid. If it is only OH and C is attached with the carbon with which alcohol group, yeah, OH group is attached, it is not attached with other oxygen atoms. So it means it is alcohol. This one is alkyne. Alkyne functional group. Okay, got it?
Yes, sir.
Yes, sir.
Next again. Which functional group is present in this one?
It's
Sir,
OH, sir.
Sir, OH, sir.
OH.
OH is nothing.
Alcohol.
Only
Alcohol.
this one.
Uh, Oxalic. No.
It's a carboxylic acid.
Yeah.
Carboxylic acid.
Acid.
And this
Yeah.
one?
This one. Sir, ketone, sir. Ketone.
Yes, it is ketone because
Because
C
there is like a C double bond O in
Yes,
is
between.
in between. Okay,
Yes.
this is also C double bond O, but it is not in at the time. Means ketone group is not cannot be attached on the termination carbon. This one,
C double bond CH.
this is alkene, only double hydro. Okay, the previous one is alkyne. Why? Because it is triple bond there. Okay, got it? Understood?
Yes, sir.
The
So what do we
concept.
call this? What do we call
The
this?
name should be given. Name we will going to write it. We will going to discuss. First of all, let me ask you that how you are learning that. Will you be able to identify the functional group? Okay, which functional group is present in this one?
CS3. Okay. One.
Tell me. This is CO. You can check it in the ketone. Ketone, I have written ketone like this. Ketone. This is CO. or it is C double bond. Structure is C double bond or like this. CO is ketone.
Okay, sir.
This one. Take the help of your notes that you have copied.
Carboxylic acid.
Yes, this is carboxylic.
Sir, carboxylic acid.
Yes, Adil, why are you not answering any? Adil, you need to answer what is the functional group of this one?
Sir, aldehyde something.
Aldehyde.
Yes, it is aldehyde. CHO, this is?
Alcohol.
Alcohol, sir. Alcohol.
Adil, are you there?
Yes, sir.
So why are you not answering the question? Next. So now we shall be moving toward the IUPAC name. That how we are just going to write the name of the simplest one. Okay. So IUPAC naming. Okay. So first of all, IUPAC is International Union for Pure and Applied Chemistry, and there are some rules how to write the IUPAC name of the hydrocarbon. Okay. So this is okay, C double bond. Example. First rule is select the rules. Okay, IUPAC naming rules. We are just discussing this one. So first rule is select the longest carbon chain. Select the longest carbon chain, including functional group. Okay, including the functional group, followed by double and triple bond. What does it mean? For example, if we have this hydrocarbon. Okay, so if you count it like this way, 1, 2, 3, 4, 5, this is the longest carbon. If you took it like this, 1, 2, 3, 4, 5, 6. So this is the longest, which is of 6 carbon. Select the longest carbon chain always. Okay, now this can be written like this: 6 carbon in a straight chain, 1, 2, 3, 4, 5, 6. I've written 7. 1, 2, 3, 4, 5, 6. Okay, and this 2 carbon will be considered as a chain, and it is on the third carbon. So this is on the third. 1, 2, 3, 4, 5, 6. So this is on the third carbon. So this is from the starting. You can write it like this way. Okay, this is on the third carbon. So this on this structure is same. This is structure and this structure is same. Okay, so always select the longest carbon chain. Always select the longest carbon chain. Okay, okay. Now if I make this structure like this way. Okay, 5 carbons, 1, 2, 3, 4, 5. And I'm just having this branch here and OH group here. Okay. So if you go through like this, 1, 2, 3, 4, 5 here. If you go like this, 1, 2, 3, 4, 5, 6, 7, 8. So you cannot take this one. You cannot take it like this one. It will be considered as wrong. Because the functional group carbon to which functional group, if a functional group is attached or having its own carbon, if a functional group is having its own carbon, like aldehyde has its own carbon, carboxylic acid has its own carbon, ketone has its own carbon. Okay, so the carbon, if a functional group is going to have its own carbon, then that carbon should be in the chain. Or if a functional group is not going to have its carbon, like this alcohol don't have its carbon. Okay, so we will say that the carbon with which the functional group is attached, like this carbon, okay, with this carbon alcohol is attached. So this carbon should be in the chain. This carbon should be in the chain. So this is not the right way how to select the chain. So you have to select like this: 1, 2, 3, 4, 5, 6. Now you can choose it 1, 2, 3, 4, 5. It is 5. Now if you go like this 1, 2, 3, 4, 5, 6. So it will be 6 like this. So you, instead of selecting the longest, you need to keep in mind that when you are selecting the longest carbon chain, if the carbon chain is going to have the functional group, then the carbon with which functional group is attached, that should be in the chain. Got it? Got it?
So
Got it?
can you explain it again?
Yes, I can explain you that if a functional group is attached, okay, if a functional group is there, okay, you can select the longest carbon chain. The first rule is select the longest carbon chain, including the functional group. If functional group is there, if there is no functional group, right? Imagine there is no functional group here, only the carbon. Then you will select the longest carbon chain like this way, because this is the longest carbon chain. You can go 1, 2, 3, 4, 5, 6, 7, 8. You can select the 8 carbon in the longest carbon chain. But if I am having OH group here, so the carbon with which this functional group is attached, that should be in the chain. You cannot go like this. If you go like this carbon is left out of the chain. So you have to select it like this way. Now you have to select the longest carbon chain, including the functional group. So if you go like this way, 1, 2, 3, 4, 5, you are going to have 5 carbon. And if you go like this, 1, 2, 3, 4, 5, 6, so it is going to have 6. So longest carbon chain will be like this. Got it? Got
Yes,
it?
sir.
So please note it down. First rule is select the longest carbon chain, including the functional group. Done?
Yes.
The next rule is the rule number 2. The numbering should be done in such a way when you are going to number, because we need to write the position of the each functional group. For example, if the functional group is attached here, which, okay, if the functional group is attached at chlorine here, okay, where the functional group is attached, we need to write the number of carbon. So we can do numbering like this: 1, 2, 3, 4, 5. We can do the numbering 1, 2, 3, 4, 5. Okay. So there is a rule that how can you can start from left to right, you can start from right to left. But how you are going to start the numbering, there is a rule for numbering. You have to start the numbering like this way, that the functional group with which the carbon is attached, it should get the lowest possible number. For example, if you are going to start like this, for example, here, if suppose alcohol is attached, and if you are going to write the name of this one, so how will you do the numbering? If you do the numbering like this, 1, 2, 3, 4. So here, this carbon with which alcohol is attached, alcohol functional group is attached, you are getting this at 4th position. Okay. And if you start numbering from here, 1, 2, 3, 4, 5. So here it is attached with the attached at the 2nd position. So we have to, for this case, we have to, it is must that we have to start from left to right. Sorry, right to left. Got it? From right to left, we have to start numbering. Okay, we cannot do this one because it will gives you 4th number of for this one alcohol, which is incorrect. Okay. So, okay. And you need to keep in mind that those functional group that has its own carbon, like alcohol, okay, carboxylic acid, aldehyde, okay, and termination ketone is an exception case that it cannot be attached. Otherwise, this carbon, aldehyde and ketone carbon should be given as number 1. Okay. For example, if you do it like this way, if alcohol is if carboxylic acid functional group is attached like this way. Okay, so don't give it 1, because if you select the longest carbon chain like this way, you cannot select. If you select it like this way, it means that the carbon of the functional group you have left out of the chain. You have left it out of the chain. You have not selected that carbon. If the functional group having its own carbon, then that carbon should be in the chain. And for in case if like this is alcohol, alcohol is attached the second. So this carbon should be in the chain. So if you do the numbering, okay, if you have in case of alcohol, you have to select the longest carbon chain like this way. But in case of in this case, you have to select the longest carbon chain like this way, because you have to bring this carbon in the chain. And now if you have bring this carbon in the chain, then this carbon should be given the lowest possible number. So we will start numbering like this way: 1, 2, 3, 4, 5. We cannot start the numbering like this way: 1, 2, because if you give 2 and then 3, then 4, then 5, it means that you have left this carbon. You have not bring this carbon in the chain. This is out of the chain. Okay, are you getting my point? So what is the rule for the numbering? The rule for the numbering is that the numbering should be done. The numbering should be done in such a way, that the functional group should get the lowest possible number. Are you getting my point?
Yes, sir.
Okay. And first of all, there is a preference. The first preference should be given to carboxylic acid. I mean, the shortest number should be given to carboxylic acid, then aldehyde, then ketone, then alcohol, then nitro, NO2, chloro, bromo, iodo, or alkyl group. Okay, those means those number, that is a prefix is given to you, means prefix. And before that, we have to give the double bond and triple bond. Means after the alcohol, we have to give the preference to the double bond and triple bond. For example, like this. Here, if it is alcohol group is attached, and here if it is chloro group is attached. So this is, if we write it 1, 2, 3, 4, 5. So here, if you give 2 number to this one, then this carbon will say 4. So it means that you are giving the shortest number to the chlorine group. But chlorine is not in the preference first. In this chlorine and alcohol, the alcohol is in the preference first. So you have to give the shortest number to this alcohol. So you have to start numbering like this: 1, 2, 3, then 4, then 4, and then 5. Got it? Got it?
Yes, sir.
Karishma, Abdullah, you got it?
Yes, sir.
So the numbering should be done in such a way that the functional group should get the lowest possible number. Have you noted this one?
Yes, sir.
Yes, sir.
The third rule is that if we have more than one prefix, then their name should be written in alphabetical order. If we have more than one prefix, means those hydrocarbons or those group which is going to have, like we have CH3 one, and one we have C2H5, and one we have, oh, not C2H5 here. Okay, one we have C2H5 here. Okay, and one we are just going to have chloro. So the name of this functional group of this branch is methyl. And how we get methyl, we will learn it. This functional group name is chloro. This functional group name is ethyl. Okay, so we can number it like this. If you start with a 2, so you can start either from here or either from here. It's your choice. So 1, 2, 3, 4, 5. Because, or if I write it the one alcohol group here, so then the numbering will be must that you have to start from here: 1, 2, 3, 4, 5. Because this functional group is given the first preference. Okay. Now, you can, when you are just going to write the prefix, and how we are just going to write the prefix, we will learn it, that how prefix we are going to write. But when we are just going to write the prefix means the first part of the functional or IUPAC name of a compound. A name, or we can say that the IUPAC name of a hydrocarbon has the following parts. One is prefix first, then we have root, then we have saturation indicator, and then finally at the last we have suffix. Suffix is at the last. Okay, So prefix should be, when we are just writing the prefix, okay, then you need to keep in mind here that if there is more than one prefix is present, then their name should be written in alphabetical order. Like you cannot write M-methyl first. You cannot write 2-methyl, okay, and then 3-ethyl, okay, and then 4-chloro. No, you cannot write like this. You have to write 4-chloro first because C come first. You have to write, the correct order is 4-chloro. After C we have E, then 3-ethyl, and then 2-methyl. Okay, got it? Whether they are at the greatest number or larger number, but their name should be written in alphabetical order. Got it? Got it? So what is the
Yes, sir.
third point? If third point is, if there is more than one prefix is present, then their name should be written in alphabetical order. And the last is, if we have more than one same prefix, same, not different. If there is more than one different. If there is more than one same prefix is present, for example, here we have chloro, here we have chloro. So we use di-tritetra before their name. Okay, like this is alcohol, we'll write it because alcohol has suffix, it does not have prefix. So if I'm just going to write the name of prefix for this one, so this is first we have to do 1, 2, 3, 4 numbering. Then we write 2, 3 at 2 position and 3 position. Okay, at 2 and 3 we have dichloro. So we will not write chloro, or we cannot write like this 2-chloro and 3-chloro. No, we will not write like this. Okay, we will not write like this. We will write 2, 3 dichloro, means at 2 position and 3 position is dichloro. If we have one more chloro, so we'll write at 2, 3, at 4 we have trichloro. So we use di-tritetra before their names. Okay, like we have methyl group here. One CH3 group, methyl, we called CH3 group as methyl. This is also methyl, and okay. So we'll write it position like, if this is only one, so we will give the preference this one, because if we start from here 1, 2, 3, 4, 5. So here it is getting 3 and 4. And if we start like this 1, 2, 3, 4, 5. So they are getting 2 and 3. So this is the correct order. If there is no functional group of the suffix 1, then we will start this one like this way. We write 2, 3 dichloro. Okay, got it? Got it? At 2 and 3 position, we have dichloro. Got it, Charisma? You understood?
No, sir.
No, no.
Yes or no?
Okay, not understanding. So actually, when we are just going to have the prefix, we will practice it one. Let me teach you further. Then we're going to discuss. When you are just going to write the name, when we practice 2 or 3, then you will understood. I'm sure for that one. Okay, so first write the rule. If there is more than one same prefix is present, then their name should be written then wait a minute, compose that. Then we use di, tri, tetra before their names. Before their name. We use di, tri, tetra before their names. So let me explain you how. For example, if this is a carbon chain, how I can write the prefix of this one? So I will write the prefix because it is the same CH3 group is present and they are present in a 2 and 3 position. So we'll write it 2 at 2, 3 means at 2 and 3 we have dichloro. Dichloro. This is the prefix for this one. And the further name we have to write, but this is only the prefix for this one. Got it? If it is chloro group here, then we will write 2, 3, we have chloro, dichloro. Got it? So we'll learn it. Have you written all the rules?
Yes, sir.
Yes, other students? Adil
Yes, sir.
and Abdullah Ashraf? Noted? Done?
Yes, sir.
Okay, let's move further. Now, let me help you that how IUPAC name is written. Okay. We have prefix. First we have, then we have root, then we have saturation indicator, and then we have suffix. Okay. Prefix means these two are compulsory. These two are compulsory. Every IUPAC name should have root and saturation indicator. They prefix may be present or not, may not be present. Suffix may be present or may not be present. Okay, so if it is present, may be present or may not be. May not be. May not be. If present, it can be only one. Okay, suffix can be only one. If present, then it can be only one. Here, if I talk about the prefix, so it can be present or can't be present. If present can be one or more than one. Note it down. Prefix can be present, can be one. There can be one prefix only. There can be more than one prefix only. Suffix can be present or may not be present. But if it is present, then it can be only one. And root and saturation indicator must be. What is root? Root is the number of carbon atom in the chain. Number of carbon atom present in the selected chain, in the longest selected chain, And what is saturation indicator? Saturation indicator tells me that how this we can simply say that saturation indicator tells us that it is doubly bounded, triply bounded, or it is going to have double bond, triple bond or not. Okay, so if there is carbon double bond anywhere, we use E and E as a saturation indicator. If there is triple bond, then we use Y and E. And if there is a single bond, no double bond anywhere between carbon, mark my point, I'm just talking about carbon atom, not carbon and oxygen. So then we use A and E. And suffix is for if we have carboxylic acid, COH as a functional group, then the suffix for this one is oic acid. If we have aldehyde CHO, then the suffix for it is Al. If we have ketone, then it is on. If we have alcohol as a functional group, then we have all, okay, as a suffix. So note it down. Note each and everything. Done?
Yes, sir.
Noted?
No, someone.
Noted fast.
Sir.
Yes.
So ENE and YNE comes under root or suffix.
Yeah, we can say that it is a previous suffix, pre-suffix, we can say, but we called it saturation indicator. And in your means it is indicating whether the how much means it is saturated and saturated hydrocarbon, if it is double bond or triple bond. Okay. But suffix is actually the last suffix. Okay. All, on. Okay. Noted.
Yes, sir.
Abdullah, noted.
Yes.
Now talking about the root. If we have number of root word, okay, number of carbon. If we have one carbon, then root for this one is meth. If we have two carbon in the longest carbon chain, then it is eth. We'll use eth. If we have three carbon, we will
Approved.
use a prop.
Yes,
If we have four carbon, we
Prop.
use bute.
good.
If we have five carbon, we use pent. If we have six carbon, we use
Pen.
hex.
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 Okay. And similarly, if for the alkyl group, root or we can say prefix
So
for
if we have
alkyl group,
7,
prefix for alkyl group. Okay. So if we have one carbon chain, any one carbon branch or alkyl group, then its name will be methyl. Two carbon chain, its name will be ethyl. Similar, propyl, butyl, pentyl, okay,
pentine,
and
pentine.
hexyl.
Yeah. Hexyl.
Okay. Next is if we have seven carbon as a root, then it is hept or sept. Hept, we use hept. Normally we use hept. Hept for seven carbon. For 8 carbon, we use oc. For 9 carbon, we use non. For 10 carbon, we use dec. Have you noted?
Yes, sir.
Everyone?
Mm. Yes, sir. So if, like 7, 8, 9, 10 are like not in the portion for us, right?
Yeah, it is. It can be. Done. So how we are just going to write the name? For example, if we have this carbon, okay? How can we write the name of this one? This is the simplest one. Or this can be written as CH3, CH2, CH3. Or it can be written as C3, C3H8. Okay. What's the name of these three? All three have the same name. Okay. What's the name of this one?
Propane.
Yes. It don't have the prefix. Prefix is not there. It don't have the suffix because it's not having any functional group like alcohol, aldehyde, ketone, carboxylic acid. So it is should be root and the saturation indicator. So you will write the root. Root for carbon is 3 carbon is prop.
Prop.
And there is a
Prop.
single bond between carbon atoms everywhere. So we will use saturation indicator as ane. So its name is propane.
In.
Okay.
Propane.
What if I make it like this? CH2, CH, CH3. Or its name is C3H6. Okay. What should be the name for this one is? Prop.
Propyl.
It's the
Propene.
propine. Propene. Yeah.
Propene. Because it is double bond, na? If it is triple bond, then wine. Okay. Okay. What should be the name for this one? Or we can write it CH3, CH2,
C3H.
CH2OH. What should be the name for this one?
Sir,
Is it?
the propanol.
Propanol. Yes. Prop for 3 carbon.
Yeah.
We do
Which
root.
is all.
Yes.
And
And then
then
saturation indicator between carbon atom is saturation
A.
indicator
No. All.
ANE. Okay.
Yes, sir.
And then suffix
OL.
OL. But you need to keep in mind here that these two vowels cannot be written in an English alphabet when we are just writing in English word. So this E will be cut from here. If we are not having any functional group, then it is propane. Okay, but if you are going to write it with, if you have to add suffix, which is starting with O, vowel word. Okay, so we will start it verb in all. Okay, got it?
Yes, sir.
What should be the name should
Yes.
to this one? What should be the name? of this one?
Butanol.
Butanol.
It
Yes,
is
sir.
not butanol. It is not butanol.
So C for OH group, it means that OL and then
So
root
what
is
is,
one.
first of all, it is going to have prefix.
Yes,
One carbon chain prefix is methyl. First of all, you have to number 1, 2, 3, 4. So at 3 position we have methyl. So you have to write 3 methyl. Okay, got it? 3 methyl.
Yes.
yes,
Then
sir.
how many carbon are there? 1, 2, 3, 4. For 4 carbon, now we have done the prefix. After prefix we have root. Root for 4 carbon is bute. So write bute. Then we have carbon carbon single bond. Okay, everywhere carbon carbon single bond. Carbon oxygen is not, I'm not talking. Okay, carbon carbon single bond. There is no double bond anywhere, so we will use ane. Okay, double bond, because we are just going to have suffix. So this is carboxylic acid, and for carboxylic acid we have oic acid as a suffix. So we'll write oic acid. 3-methyl butanoic acid. Got it?
Yes, sir.
Yes.
Okay. So if I ask you, what is the formula? What is the name of this one? Identify and name the functional group. Only if I talk about that, what is the name for this one? What is the name for this one?
Is it again propanol?
Yes, it is prop in all. What is the name for this one?
Yes, sir. And double bond and OH is oic. So propanoic.
Prop in oic acid.
Yes, sir.
Okay, this one.
This one
Yes,
is
this one.
double bond. So ENEs and 4 is boot. So uh, boot and
Butanol.
Why butanol?
it's not L, it's L. So
Butanol, bute, there is not any functional group is there. Only the double bond is
Okay,
there.
okay, okay.
in
Mm,
This is butene.
butene.
In,
butane.
why not in butane? If it is single bond, it is butane.
Because it's double bond.
Yes. What is the name for this one?
Uh, Again double bond and O. So ONE. So 5 carbon, pen, and then on penton. Is it?
Not pent, then single carbon carbon single bond, saturation indicator. This is the root. Then
Yes,
saturation
sir.
indicator, carbon carbon single bond, ane. And this is the ketone group. Okay. Okay. Then it is on. Pentanone. Got it?
Yes, sir.
Pentanone. Why
Yes, sir.
not in here? Because we are not talking about the carbon 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 and oxygen double bond. We are talking about, if it is in, it means that carbon carbon double bond should be there. Okay.
Okay,
Otherwise,
sir.
okay. So now I hope you understood. We will. This is the first class for this IUPAC, so it will take 2 or 3 more classes to understand this one. So I will take start a little portion from this one, and then we'll move forward. Okay, so we just practice 10 to 15 minutes the IUPAC name, and then we shall be moving further. Okay, so this will help you to understand and keep in memory. Okay, so that's all for today. We'll meet in the next one. You may leave if you wish. Okay.
Sir, is there an assessment?
Yeah, no assessment for this class. Let me check.